Okay, here we want to look at the following third order homogeneous linear differential equation with constant coefficients. So it's given by y triple prime minus 2y double prime minus 5y prime plus 6y equals 0. So as is standard, we want to look at a certain complementary polynomial which will aid us in solving this. So we want to consider the polynomial u cubed minus 2u squared minus 5u plus 6, and we want to find the roots of this polynomial. So in general, it's pretty hard to factor a cubic polynomial, but if we recall the rational root theorem, so I won't write it on the board, but the general idea is a good place to look for rational roots of this polynomial are all of the factors of the constant term plus or divided by all of the factors of the highest order term, and then include a plus or a minus. So we see that 6 has factors given by 1, 2, 3, and 6. And then 1 has factors given by 1. So that means possible rational roots will be of the form these factors divided by these factors. So we have plus minus 6, plus minus 3, plus minus 2, and plus minus 1. So now I won't check all of these, but if you notice that positive 1 works. So if you plug 1 into this, you get 1 minus 2 minus 5 plus 6. And that will work for us. So in fact, if you do 1 plus 6, that's 7, minus 2 minus 5, so that's also negative 7, so everything will cancel. So that means 1 is a root. So notice u equals 1 is a solution. Now you have two choices. You can keep plugging in these possible roots into this equation in order to find its complete factoring, or now that you know one thing is a root, you can use long division of polynomials. So that's what we'll do. So now we'll divide u minus 1 into u cubed minus 2u squared minus 5u plus 6. And since we know this is a root, we know there will be no remainder. So now what do we need to multiply u in order to get u cubed? So that'll be u squared. So now u times u squared is u cubed minus u squared. And now we'll subtract this whole thing, which means we'll get u cubed minus u cubed is 0, and then we'll get negative 2u squared plus u squared, so that'll be minus u squared. Good. And now we'll bring down the negative 5u plus 6. Now we need to find out what do we need to multiply by u to get minus u squared, and that'll be minus u. Good. So now that'll give us negative u squared plus u. Fantastic. Now we can subtract this whole thing, and notice that'll give us minus 6u plus 6. Good. And then finally, negative 6 will end it all off, and that'll give us 6u minus 6, but now we need to subtract that, and notice we get a remainder of 0. So that tells us that our original polynomial, u cubed minus 2u squared minus 5u plus 6 equals u minus 1 times u squared minus u minus 6. Okay, good. So I'll clean up the board and then we'll finish it off. Previously, we had decided that 1 is one of the roots of this polynomial, and then we used polynomial long division in order to factor it as follows. So now we need to factor this quadratic polynomial, which is a little bit easier. So we want to look for two numbers that multiply to negative 6 and add to negative 1. So that's not too bad. We get u minus 1 and then u minus 3, u plus 2. So that means the roots of our polynomial will be 1, -2, and 3. So that tells us that the general solution of our differential equation will involve exponentials according to these numbers. So we have e to the 1x, e to the minus 2x, and then e to the 3x. But now if each of these are solutions, then if you take linear combinations of them, those are also solutions. And so that is the way to build the most general solution to this differential equation.